So a ratio is a comparison of two, we'll call it quantities, because it can be anything. So you can compare, for example, the number of men in a class to the number of women in a class, or the number of teachers to students. And in some cases, like if you think of, if you have kids, they have ratios for classrooms, and that way you can determine how many kids per teacher and see if they're getting enough one-on-one time with their teacher. Also, ratios are used for things like cooking, lab, all sorts of mixtures involving labs. They're used all the time. No, that was it. That was the email. So that's all they are. We can just compare two things. The most important thing is that you pay attention to the order that they're asking things in. So we write ratios in three different ways. First, we write them just with the word to between them, like A to B. Or they use colons to represent ratios. And also, they'll put them in fraction form. So these are the three ways you write them: with the word to, with the colon between them, or in fraction form. And again, the order does make a difference here. So it says here, we can write a ratio that compares the number of females in the room to the number of males in the room. We're not really in a room anymore, but let's see if everybody's still on. We've got 2 males and 9 females. So it would be 2, 2, 9. In any of those ways, you could write it with the word to between it, like I said before. You can do fraction form. But if they want, let's see. Oh, I did it backwards. They want females to males. So this is exactly what I'm talking about. If you want in that order, we got to make sure that we do it in the right order, because it makes a big difference. Think about, for example, if you are mixing something. Let's say you have to dilute bleach to clean. If it says you're supposed to mix 9 parts water to 2 parts of bleach, and you do 9 parts bleach to 2 parts water, that could potentially burn somebody. Same thing with any other chemicals when you're working in a lab, food, all of that, it matters. So the order does matter. Pay attention to what they want and keep it in the order that they're asking for. So females, here's the word to, that's my indicator that the other one is coming. And then males. Okay, now, here's where actual calculations will come in. Oftentimes, ratios are given, they're given either too large or too small, and we have to go one way or the other. So if you're given a ratio that's too large to work with, you can simplify it. So basically, you're going to treat these like they're fractions. So if you have a ratio that has whole numbers, you're going to treat it like a regular fraction. You're going to put your ratio in fraction form and then simplify it like we did in the last chapter. But with decimals and fractions, then we got to do a little bit more work. So when we get to those with the practice problems, I'm going to go through the steps with that. So first I want to go to question like this one here. It says, in a hospital, there are 100 nurses. 65 of them are female. So what is the ratio of male nurses to female nurses in lowest terms? So let me jot it down real quick, and then we'll go to the whiteboard. You've got 100 nurses. That's your total. 65 of them are female. And they want male to female in lowest terms. All right, so let's take a look and see what that looks like.
35 to 60.
Yep. All right, so here is my information here. If they want males first, then we got to figure out how many males there are. So we know that there's 100 total. We know that 65 of them are female. So the other part of this must be male. So if I just subtract, then that's 35. And those must be the males because 35 plus 65 is 100. So now I got to give it in the right order. And I have to give it in simplest terms. So I'm going to go to the males first over the females. And then I need to simplify this just like it's any other fraction. They're both divisible by 5. So 35 divided by 5 is 7. And 65 divided by 5 is 13. So here's my ratio in lowest terms. Which is why we talked about fractions before we did all of this. Okay. Number 2 has decimals in it. So I'm going to read it first. I'll get it written down, and then I'm going to go back to the directions and talk about it. So the width of the notebook is 3.5 inches, and the length is 6.75 inches. Express the ratio of the length to the width as a ratio of whole numbers reduced to lowest terms. So just like before, let me jot this down real quick. It's 3.5, 3.5 inches, which is the width, and 6.75 is the length. And they want the ratio of the length to the width. Okay, so let's talk about what they mean by whole numbers and then reduced to lowest terms. So whole numbers means these decimals have to go away. These are not whole numbers, they're decimals. So we need to change them to whole numbers and then reduce it to lowest terms the way we did the first problem. So here are the steps. If you have a ratio involving decimals, first we're going to write it in fraction form. So let's go back and get it in fraction form according to the order that they're asking for. So the length comes first. And then the width. So I'm getting it in fraction form first, but it looks pretty ugly because there's decimals inside of a fraction. So there's a lot going on so far. So let's see what it says next. Step 2, move the decimals to the right the minimum number of times needed to make them both whole numbers. So let me show you what that means. So if I look at these 2 decimals, I need to move my decimal over to the right, it tells me. So if I move it once at the bottom, I'm just starting at the bottom just to make a point here. So if I move it once in the bottom and put it after the 5, that's now 35. And there's no more decimal, so that one is good. Whatever I do to the one, I have to do it to the other. So if I move this one time, now it's 67.5. I did not get rid of my decimals completely then. So moving it once is not the minimum number of times needed to get them both in whole number form. In this case, I got to move them both twice then. So let me move it one more time, and that'll put it behind the 5 instead. So basically, it's going to be 675 now. My decimals in the back. And if I do twice to the top, I got to do twice to the bottom. And that means I need to add a 0 to this one to make them both whole numbers. So now I've got a fraction with no decimals anymore. And that's what step 2 is telling you to do. Okay, move the decimals to the right, however many times is needed to make them both whole numbers. So now they're both whole numbers, and then we're going to go to the simplifying. So I'm going to look at this here and try to find something that I can divide those both by. So since one ends in a 5 and one ends in a 0, I can divide them both by 5. But I also just happen to see that I'm ending in a 75 and a 50, and that means I can divide them both by 25, which is the biggest one. So just to save some time, I'm going to go to that. If you do 5, you'll have to do it again, but you'll get there. It's fine. So let's see what we got. 675 divided by 25 is 27. And 350 divided by 25 is 14. And nothing else simplifies this, so this is done. So here, now we have a ratio of whole numbers, because there's no more decimals, and it's in lowest terms. The next one. So to practice the decimal thing we just did, we're going to do another one. So in preparing specimens for testing, it is often necessary to dilute the original solution. The dilution ratio is the ratio of the volume of the original solution to the total volume. Determine the dilution ratio when 2.8 milliliters of blood serum is diluted with 47.2 milliliters of water. So this one is a little bit more complicated due to the nature of the problem, but we're still going to set it up the same way. I'm going to jot everything down. I'm going to write down what they're asking for, and then we'll set it up. So we've got 2.8 milliliters of blood. And 47.2 milliliters of water. There's our given information, and they want the dilution ratio. Determine the dilution ratio. And then they told us prior to this what a dilution ratio is. The dilution ratio is the ratio of volume of original solution to the total. The original solution is whatever it is you're working with. So in this case, it'll be the blood serum. So we need original solution. And again, that's the blood. It's whatever you're working with, whatever you're diluting. We need that to the total volume. Okay, let's see what we can do then. Here is everything that we have. So the original solution, we're just going to pick it out of the given information. That's a 2.8. And we need to put it over the total volume. How are we going to figure out the total volume?
Add those other two together?
Yeah, just add them up. 47.2 and 2.8 is 50. Total means add, so just add up the two things you're mixing together, and that'll tell you your total volume. So this is going to be 50 down here. In a question like that, that's the part that people mess up the most, is they don't read it carefully, and they don't stop to think what they mean by total volume. They put it in as 2.8 over 47.2, but that is not a dilution ratio. A dilution ratio has a specific definition and is always this way. Solution over total. It's not solution over dilution. There's no such thing as that. Okay, so here is my ratio set up. And now, since I've got to deal with the decimal, I'm going to move it over to the right. In this case, I just need to move it one time. And that'll put it behind and make it at a whole number. And then if I move it in the top once, I got to move it in the bottom once. So it's starting after the 0. It's 50. The decimal's after. So then move that over once, and now it's 500. Okay. Also, I didn't mention it in the last problem, but since these are both milliliters, they would cancel out, just like if you had a question something like this. 2 divided by 2 is just 1. They just cancel out. Milliliters divided by milliliters is like multiplying it by 1. Those just cancel out and they're gone. All right, so over here, I just need to reduce. So I need to find something I can divide those both by. Anybody think of anything?
4.
Okay, let's try 4. 28 divided by 4 is 7. And 500 divided by 4 is 125. Whoops. And that doesn't go down any further, so here is your dilution ratio as whole numbers in lowest terms. Okay, so number 4 says Wayne walked 2 1/3 miles on Monday and 3 8/9 of a mile on Tuesday. Write the ratio of miles walked Monday to miles walked Tuesday as a ratio of whole numbers reduced to lowest terms. So let's jot it down. She walked 2 1/3 on Monday and 3 8/9 on Tuesday. And they want the ratio of miles walked Monday to Tuesday as a ratio of whole numbers reduced to lowest terms. Okay, so let's, before we go to the whiteboard, let's go back up here and look at this last box. This is how we simplify ratios that involve fractions. So you have 2 mixed numbers as your starting information. So your first step is going to be to change those mixed numbers to improper fractions first. Next, you're going to divide them. But we're not going to set it up quite the same way as we've been doing. We're going to divide it, we're going to write it out horizontally so that we can simplify it at the end. So I want to back up for just a second here and show you why we're doing it this way. Way back up here, when you look at the 3 different ways that you can write a ratio, if the third way involves a fraction, and a fraction bar means division, that means that a colon means division, and so does the word 2. All of those meant divide the whole time. So when I go to set these other ones up that we've finished doing, I was putting them in fraction form, and I was basically dividing them out. When we're working with these 2 now, I'm still going to divide them. That part's not changing, but the way that it looks is going to look a little bit different than what we've been doing. So let me show you what I mean. So here's all the information I've got. If I set this up the way we've been doing, just bear with me for a second, I would put 2 1/3 over 3 8/9. And I'd have to deal with that. That looks like a mess. This is called a complex fraction, when you have fractions divided by fractions in fraction form. You've got multiple stuff going on here. I would prefer not to write it like this. Instead, since I know that a fraction form means divide, I'm going to write it this way. I'm still dividing, but it's a little bit easier to deal with. Because from here, now if we follow the steps on the page, we're going to convert these to improper fractions first. So it's going to be 3 times 2, which is 6, plus 1, and that's 7. Keep the denominator. Then do the same thing for the other mixed number. 9 times 3 is 27. And then 27 plus 8 is 35. And we'll keep the denominator. And now, based on what we were talking about prior to this class, when you're trying to divide fractions, you keep, change, and flip. You multiply by the reciprocal. So we're going to keep the first fraction. We're going to flip the second one. And then your division changes to multiplication. Again, this is why we reviewed all of this prior to this. Now that you're multiplying, this is also when you are allowed to do the canceling if you see it diagonally. So, for example, the 3 and the 9 can both be reduced. And let me grab another color here. The 7 and the 35 are both divisible by 7. Oops, wrong one. 7. 7 divided by 7 is 1. 35 divided by 7 is 5. I can't do anything else with that, so I'm just going to take it straight across. And here's our final answer. So, all the way back from the top here. Monday and Tuesday, instead of writing it complicated and writing it as 2 1/3, we can convert it and make it 3. And then Tuesday, instead of writing it as 3 8/9, it's like converting it into a 5. So, any of those would work to answer. All right, so we're just going to do a few more practice, and then that's it. So here's another one. Let me erase this. Okay, so blood contains 3 types of cells: red blood, white blood, and platelets. For approximately every 600 red blood cells in healthy humans, there are about 40 platelets and 1 white blood cell. They want the ratio of red to platelets in lowest terms. So let's write down what we got here. There's about 600 red cells, 40 platelets, 1 white. And then they want red to platelets. Did they ask for white blood cells?
Nope.
Nope, so you don't even need it. Just extra information. Let's set it up. So we need the red over the platelets. Okay, the zeros can cancel out right away. And then we've got 60 over 4, and we just need to figure out what we can divide those both by.
40.
Okay, so, well, it'll be 40 if we keep the 0, 4 if we knock the 0 off. Okay, so 60 divided by 4 is 15. 4 divided by 4 is 1. So here's my answer. Now, this is something we haven't looked at yet. Can I do this?
No,
Why not?
because it's just 15.
Right. In ratios, you need to preserve both numbers because they represent something now. Before, depending on what you're doing, this one could be dropped and just changed to a whole number. But this is for every 15 red blood cells, there is 1 platelet. If you drop the 1, it's just 15 red blood cells, and you don't know anything. You're not comparing it anymore. So keep the 2 numbers. Even if it's a 1, you want to keep it so that you preserve the ratio. Does that make sense?
Yeah, because you got 2 they want to know about 2 things, so you can't just put 15.
Right.
It got to be 15 blood to 1 plate.
Right. And for some people, it still doesn't really make sense because they're not used to working with cells and things like that. So let me try to give you a different example, just in case. If they told you to mix, I'll go back to the example I used before. If they told you to mix 15 parts water to 1 part bleach, and you drop the 1, you just have a bucket of water. There's no bleach in it. So you need to preserve the 2 amounts because they represent 2 different things now. All right. Let's look at number 6. All right, so a newborn baby has about 300 bones, and an adult has 206. Express the ratio of bones in an adult to that of a newborn baby of bones. All right, this one's pretty straightforward. Let's just write everything down. 300 bones in an adult, in a newborn. And 206 in an adult. By the way, without looking even what the problem told me, I knew that I had mixed that up because babies will always have more bones than adults. And if you're not familiar with why that happens, it's because their bones are not fused yet. And once they become a little older, they fuse and they become like 1 bone, like for example on their skull. All right, so let's go. Oh, hold on, what did they want? They want adult to baby.
They want adult to baby. We put the adult on the top and the baby on the bottom, right?
Yep. Yep. And I would spend that extra second and write that down so you don't flip them around because they will oftentimes give you the information in one order and ask it in the opposite order just to try to trick you. So adult is 206, baby is 300, and since these are whole numbers, I don't have to do anything other than just simplify it like we had to do in the last one. So what can I divide these 2 both by?
2.
Yep. And that's actually the only thing that works for both of these. So 206 divided by 2 is 103.
Over 150.
Over 150. There you go. All right. Number 7's got the decimals. So let's take a look at that. Canton experienced 2.4 inches of rain in October. In November, there was 0.4 inches more rain than in October. write the ratio of rainfall in October to November as whole numbers in lowest terms. So let's write down what they told us. It's 2.4 inches of rain in October. And then in November, there was 0.4 inches more rain than in October. So they're trying to be tricky here. I'm going to write it down.
Answer was 0.6.
And then they want the ratio of October to November. All right, here we go. All right, this is everything they told us. There's 2.4 inches of rain in October. That's straightforward. And then in November, it says there's 0.4 inches more than October. So if we go back all the way back to the very first day when we talked about problem solving, we need to translate this into an expression. More than means plus. So it's 0.4. Let me scoot this out of the way real quick. (0.4) plus whatever it said was October's amount, which was 2.4. And that'll tell us how much we got in November, or that Ken got in November. So 0.4 plus 2.4 is 2.8.
2.8.
And that was November's rainfall then. So just be careful. They're going to try to trick you with doing stuff like that too. Now, let's put them in our fractions. It's going to be 2.4 first. Over November, we just figured out was 2.8. These two can actually go. All right, now we have to deal with our decimals. So we'll move them both over once, and that'll put them in whole number form. So now it's going to be 24 instead, and 28. And then the last step is to just simplify. So we need something we can divide these both by.
6/7 is the answer.
Yep, both divisible by 4. So 24 divided by 4 is the 6 that he said. And 28 divided by 4 is the 7.
Wow.
Sorry. All right, so that one's done. And this is our last one.
Class. So, no, we make it over here.
All right, so write the ratio of 2 and 5/8 feet
All right, yeah, I just want to
to
everything.
7/6 feet. Is a ratio of whole numbers in simplest form. So let's take a look.
Yeah.
All right, so this one that has fractions in it. So rather than go through fraction form with fractions and make a complex fraction, we're just going to do a division sign between them. Because 2 means divide. So we'll set it up like this. Then we need to convert this mixed number. So 8 times 2 is 16, plus 5 is 21.
Well, I mean, they were trying to charge me 6 cents, so we put it with, so yeah. Right.
And then since we're dividing, we're going to do keep, change, flip, and multiply.
Yeah, that's fair. 350. Okay. Okay, man. I'll see you when you get here. Yeah.
Okay, now we're multiplying, so now we can look to see if anything cancels. Let's see, I'll look at the 21 and the 7. They're both divisible by, oops, let's, multiply 7. 21 divided by 7 is 3. 7 divided by 7 is 1. And the other two, 8 by 2. Hey, Aaron, can you mute yourself? Um, 8 divided by 2 is 4. And 6 divided by 2 is 3. And that's it for simplifying, so let's take it straight across. 3 times 3 is 9. And 4 times 1 is 4. So there's our ratio as whole numbers now in lowest terms. All right.